Alrighty. If I have two situations here, so situation 1 and situation 2. I give you the equation here, and after I give the equation, I want you to graph it, write the table and a sentence for that. So what is easiest, it just depends on the individual, but what I'm going to do is I'm going to start with the graph. I think that would be a pretty easy one to start with. And for a graph here, I'm going to go by 1, 2, 3, 4, and let's see. I'm going to go here. Well, what number should I go by? Well, with this graph, don't we start with 6, and we're dropping by 3? So don't I for sure have to be at least 6 high? Let's see. 1, 2, 3, 4, 5, 6. Do I fit?
Yeah.
So I can go by 1s. 4, 5, 6. So I can go by 1s both directions. So all I'm going to do is graph this. I said, again, we started at 6, so I'm going to put a dot at 6. And we drop 3 every time. What that means is, when I go over 1, I drop 3. Over 1, drop 3. So can I put those dots? Can I then make my line? That right there is your graph. Done. So if I want the table, well, could you simply plug in 0, 1, and 2 into the table? Or could I just look at my graph? I can just look at my graph. So my 0 was 6. And then my 1 was a drop of 1, which is right here at 3. And 2 is right here at 0. Meaning I started with 6, and I kept dropping by 3. So depends on what steps you want to go. I kind of like to do the graph first, then the table. These are all 3 the same thing, just different representations. The last one's the sentence. And I'm just going to go with the sentence as I start with what? I start with 6, and am I increasing or decreasing? I decrease by how much? By 3 each time. There we go. Now, could you add a scenario, like you had money and you're spending it? Yeah, or you could just say you start and shrink. There we go. We have now done these all together. Now we got to think of this one. Now we got to think of this one right here. So we're starting with the table. For a lot of you, a table to a graph is an easy start. So let's do the graph. Mark that right there. By the way, we're just doing first quadrant. We could do more quadrants, but I'm going the first quadrant. Can I go by 1s?
Yeah.
Looking at these 1, 3, 5, would that fit right here with by 1s?
Yeah.
Yeah. So let's go 1, 2, 3, and so forth. So 0 is 1. 1 is 3. 2 is 5. Could you put those dots? So 0 is 1. 1 is 3. And 2 is 5 right here. And can you make a line? Okay. So what does that mean? Okay, well, I have these two. How do I get my equation? Well, can you look at the graph or the table and think, what did you start with and how is it changing?
Yeah.
Yeah, we started with 1, and we're changing by 2 each time. Aren't we growing by 2? So my equation would be I grow by 2, and I began with a what? A positive 1. So I start with 1 and gain 2. And a sentence? Well, I start with 1, and am I growing or shrinking?
Growing.
I grow, so I'm going to call that increase. Increase by, what was it we're increasing by each time?
2.
Looks like we're adding 2. So we were increased by 2 each time. So they all agree with each other. They're all 4 different representations of the same thing. And that's important to be able to do. No matter how I start, I want to be able to jump to any other representation. Now we do have a couple questions down here where we're going to compare the 2 situations and say which one it is. Alrighty, so for this next one, which function has the smallest average rate of change? So smallest average rate of change. So smallest means, average rate of change, do you understand? It means slope. So what this is saying is the smallest slope. That's what we're asking for. Or smallest slope means the least steep. So if we look at the two graphs, which one looks less steep? Well, can we look at the two slopes? What is the slope of the first graph? It's -3 versus what's the slope of the other graph? 2. Now this one can easily be messed up. Because what is the smallest average rate of change? You might look at the digit and say -3 is smaller than 2. -3. But the negative is just direction. For average rate of change, the negative is direction down. So which is actually smaller, 2 or 3?
2.
It's the 2. Catch that? Even though -3 is a smaller number, it's the negative doesn't matter. Negative is just direction. The steep, the least steep is what we're looking for, which would be this one. So what function is that? The first or the second? It is the second function. You got to be careful of that, though. Don't think the negative, again, is directional. Next, which function is increasing? Well, in our sentence, did we use the word increasing? Can you kind of see it? Yeah, we gave it right there, so we can see it by that. But if we're thinking slopes, aren't we looking for the positive slope? Or the graph that's going up? Or the table that's getting bigger? All depends on how you're looking at it. So can everybody be okay with we're increasing for the second function? Next one. Which function has the largest y-intercept? So largest and y-intercept. So isn't y-intercept your b, or your 0 value? So if you look at your table, aren't we looking right here? If we're looking at the equation, aren't we looking right here? If we look at the graph, aren't we looking right here? Or aren't we looking at the starting point here? It depends on what you look at. Any of them, you can figure it out. So which one is the largest? Well, let's see what we have. What's the first equation? 6 versus a what? 1. So which is larger? Is it 6?
6.
So that is the first, or the first equation, the first function. Last one's a little bit different. We're not used to the x-intercept as much, but I want the smallest x-intercept. So we're looking at the smallest x-intercept. So the weird thing is, does this one have our x-intercept? 2. So we have a 2 versus, what is my other one? I don't have it. Well, could you extend this down? And what you would notice if you extended it down, it's actually -1/2. Just think about that. Aren't we going, if we go down here, isn't that about, if you keep going this way, can you tell that's a -1/2? Okay. It might be hard to see, but at least you know it's negative. So which of these two is a smaller x-intercept? And this one, negative matters. Got it? Negative matters on x-intercepts. So can you tell us this one? Which is which equation?
Second.
This is the second one. Did I miss anything? All right, so we want to take what we start with and create the other representations for each. Then it helps us answer these questions. Now, could you have answered these questions without writing the other representations, just starting here and starting here? You probably could. But if you can't answer these kind of questions, could you at least make one of the other formats? I did all of them, just to practice. But on a test, if I gave you this and this, could you answer these? It all depends on how you would approach that.